Hello and welcome to Stages, the 5th episode as part of our Red Team Fundamentals mini-series. In this video, we'll be taking a look at another one of Sliver's important functionalities, which are stages. Now, in the previous video on using Sliver itself, we generated and used implants. However, you may have noticed that those implants were relatively large in size, and they often span double digits in megabytes. Now, furthermore, the format options in which those implants were generated were rather limited, as we were restricted to mainly generating DLLs and EXEs. So Sliver stages allow us to create our own implants, and in this video we will cover precisely that. My name is evasiveness, and if you enjoyed this video, make sure to leave a like and feel free to join our Discord server, for which link to I've left in the description below, to keep up to date with our content and some very exciting stuff we've got coming up at HackerForce. Now, payloads form the cornerstone of any red team operation. They comprise the software that is designed to execute instructions that a system understands, enabling unauthorized actions. Our ability to gain access to remote systems largely depends on our payloads, and a well-crafted payload is invaluable. Now, amongst the numerous actions that can be performed with the payload include executing code to establish a session with a command and control server for remote command execution, encrypting files as commonly seen in malicious software such as malware, and basically performing any task that a computer can process. Now, payloads are primarily categorized into two types. You've got staged and stageless payloads, and each of those offer distinctly different operational mechanisms. Now, stageless payloads, or implants in Sliver terminology, are the most straightforward option. They're fully prepared, self-contained binaries that incorporate both the exploit and the complete code necessary to execute the selected task. Now, if you remember, in our previous video, we generated such payloads using the generate command, as Sliver by default produces stageless payloads. Now, examining the diagram, you can observe the typical communication process for these payloads. In essence, the client first generates and delivers the payload to the agent, and once the agent executes the payload, essentially it just establishes the connection with the server, enabling us to interact with the agent. Despite their valued simplicity, stageless payloads, particularly with Sliver, are substantial in size. Due to the Go language that is used when Sliver payloads are generated, they leave behind numerous artifacts that antivirus systems can detect, flag, and subsequently block. Now, to illustrate why a Sliver implant is not really recommended for organizational use, what we're going to do here is generate a basic Sliver implant. And as we said before, basic Sliver implants are stageless. So once our implant is generated, we're going to use the ALH switch with LS to view the implant. And I believe it's statutory serve.exe. And as you can notice here, the implant size is 9.6 megabytes. Now, for a payload that just simply reaches out to a command and control server and establishes a communication channel, this is quite large, and there is quite a large area for detection by antivirus systems. In this case, when you're trying to be either evasive or when you're trying to leave as minimal amount of artifacts as possible, you would use staged payloads. So staged payloads operate differently from stageless payloads. They are not provided in a readily executable format, but rather provided as shellcode. Now, for those unfamiliar with the concept, shellcode is essentially a sequence of machine code instructions used to directly manipulate system memory to perform a desired action. Now, on its own, shellcode cannot typically be executed. It's rather incorporated into a larger payload, also known as a dropper. Now, this dropper can be any program that can load and execute shellcode. And this precise characteristic gives staged payloads their flexibility, as basically anything capable of loading shellcode can be used to execute our desired functionality. Now, we'll explore how this can be utilized with various different file formats when we discuss phishing, but soon you'll see how such a shellcode feature that staged payloads provide can be used to not only drastically reduce the size of our implant, but also leave behind less fragments, or less artifacts, that is. Now, every staged payload requires a handler to operate, and this handler essentially serves the remaining payload that is necessary for complete execution. So this means that, the shellcode can be as minimal as being capable of fetching its remaining code to fully execute. Furthermore, all of this operation can be performed entirely in memory without even writing to disk. As we saw earlier with the Stageless example, we needed to deliver the implant to the victim in order to get them to execute it. Now, of course, when we craft our own implants, we'll deliver the implant to the victim, but we'll abuse the functionality of being able to directly inject shellcode into memory. And this particular feature is, going to be further discussed in phishing. So don't really worry too much about it now. So overall, this entire flexibility makes staged payloads far more superior alternative to stageless payloads. However, staged payloads also have their downsides. These types of payloads require more outbound connections to fetch their remaining functionality, which raises the question, is it more advantageous to have host-based or network-based artifacts? Now, this will typically depend on your requirements. However, the latter option can be further obfuscated using hosting services with certificates, maybe web servers running with HTTPS and much more. Now, before we can actually start creating stages and really getting to know them, there are a couple things we need to install. Now, one of the first things we need to do on the client is install MingW, and essentially this is a cross compiler that will allow us to write source code on our Linux client and compile that source code into executables that Windows understands. Now, for the stager that we'll be building later, it will be built using the C language. And what we'll do is basically interact with Windows components through the Windows library. Now, once everything is installed, to ensure that everything has installed correctly, we can run this command here, and it's quite complex to pronounce, so I'm going to try to avoid doing that. But essentially running it with the version switch will print the compiler's version. And if everything has installed correctly, this is what you should be seeing. Now, with the compiler installed on the client, what we're going to need to do is install Metasploit nightly. And to do so, we're going to open up Firefox, type in Metasploit nightly here, and this first link here should greet you with a documentation on how to install it. Now, the reason we're doing this is purely because Sliver, the way it generates payloads is by using Metasploit. So essentially, Metasploit acts as a wrapper for Sliver to generate stages. Now, Metasploit is a command and control framework of its own. We're not really going to dive into, its complexities or anything like that. But just note that through Sliver, you can interact with Metasploit's stager generating feature to generate stages. Now, to install it, what we're going to do is we're going to copy this command here, go into our server instance and basically run it. Now, the complete framework for Metasploit will install here, so just make sure that you have enough space for everything to successfully install. So with everything installed, if we were to run the command msfvenom, we'll be able to see its various different types of options it supports. And msfvenom is essentially the utility that is used to generate stages. Now, again, we're not going to directly interact with msfvenom. We're going to use Sliver, but I would advise you to go through the list of options that msfvenom supports and just see what is possible to generate stages. So now with everything set up, before we can actually generate stages, there are just several things we need to do beforehand. Firstly, we're going to need to generate a profile, and a profile will essentially serve our shellcode. Then we're going to need to generate a stage listener, and all that a stage listener will do is essentially serve our profile. And finally, we're going to generate our stager and implement it as part of a dropper and get it running on the client. So to generate a profile, we'll use the profiles command, and before we do so, actually I'm going to list the help option for it. Now, the profiles command supports numerous different subcommands here. You've got generate to generate an implant from a profile. You've got the new command to create a new implant profile, and then also you've got the RM command to remove a profile. Now the specific command we're going to use here is new. So what we're going to do here, actually, before running the subcommand, we're going to use help profiles new, and specifically I kind of want to showcase you the various different options it supports. Now you may recognize that all of these options look similar to what it looks like when we are generating a basic implant, and that is true. Essentially what we're serving is the implant. Now instead of obviously serving an exe, as for the format, in our case we'll be serving shellcode, so we're going to be serving shellcode through the profile. Now I know all of this can be confusing, but just bear with me, it'll all make sense soon. So as the profile's new command mimics the functionality of a basic implant, we're going to specify the listener. We're going to use mTLS. We're going to specify the IP address for which the agent can communicate to. And for the format here, instead of emitting it, we're going to specify shellcode. And finally, what you're going to want to do is specify the profile name. In our case, we're going to specify Win32 mTLS. Now clicking enter will create the new profile, and using the profiles command, we can list all of the created profiles. Great, so with the profile out of the way, the next thing we're going to need to do is create a staging listener. And this is essentially that handler that will deliver the remaining shellcode. Now to actually generate the listener, we use the stage listener command. And before running the command, I'm quickly going to list the options that it supports. Now the stage listener supports numerous different options, but the ones that we are of interest are the profile and the URL. Now the URL will specify the URL for which the stager will call back to. And once the stager calls back to that URL, the backend will deliver the remaining shellcode. And the backend that implements this is specified through the profile. And to do so, we use the p-switch. Great, so once you understand everything, we're going to use stage listener, if I can spell today. As for the URL, we're going to use TCP, the IP address for which the agent can communicate to. And also here, we're going to need to give it a port. Now the port can be anything. We're going to use 8443, which is actually used by default when a stager is generated. And lastly, we need to specify a profile, and that is Win32 mTLS that we generated earlier. Now running this will start a new build, and it will actually start a new job. Now because the stage listener is actually serving the remaining shellcode through the profile, it actually needs to be a job. Otherwise, there'll be nothing to connect back to from the agent. So if we use the jobs command here, you'll see that the job for our stage listener has been created. Now, before we continue, what we're going to do is we're going to start the mTLS job, and this will be the main communication channel that will be used for when the complete stager is executed. Great, so with that done, the two jobs here are present, and the remaining thing that we need to do is to actually create the stager. Now to create a stager, it follows the similar process when creating any sort of implant. We use the generate command, but this time we're going to use the stager subcommand here. So if we list the help options for this, you can see here that it's a little bit shorter, but the main options that we're going to want here is to specify the listening host, and also we're going to specify the listening port. So using generate stager, I'm going to specify the IP address of our server, and also, you can omit this port because by default, as you can see here, it uses that port 8443 that we discussed earlier. So if you want to, you can omit this. But then for the format, what we're going to do here is we're going to specify a format of C. And what this will do is it will actually generate the stager in something that the C language understands. Now there are many types of formats. You've got Bash, C#, PowerShell, Python, Ruby, VB application, and many of these formats we'll get into when we discuss phishing, so don't really worry too much about them now. But what we're after here is the C format. So specifying C here, the last thing we're going to need to specify is the output directory of our stager. So we're going to specify payloads. And if we go into our payloads directory here, you'll notice that the stager has been generated. Now, if we actually view the top 5 lines of this stager, indeed, you'll notice that the stager is in a format for which the C language is, understands. Great, so at this point, we've got everything that we need. The last thing that we need is the actual dropper. Now, as for the dropper, we said earlier we're going to be using the Windows library to interact with Windows components. We're going to import the Windows library here, which will import 4 of these main functions. So to kind of, explain them here, the virtual alloc function, what this will do is it will allocate a specific block in memory for which our shellcode will be placed. Then, you've got RTL move memory, for which will move our shellcode that is stored as an array into that memory block. Then you've got create thread, which will actually create a thread of execution at that memory block. And then lastly, we've got wait for single object, which will wait for that thread to finish executing. Now, if you don't understand any of this, don't worry too much about it now. For beginners trying to understand how to program in C and really trying to understand the Windows API can be quite difficult. Now, we'll get into it more later in this course, but now what we're going to do is we're actually going to insert the shellcode just below this comment here. Now we're just going to save the file and exit Vim, and using this command here we're going to compile our dropper payload, and by using the compiler we installed earlier, we're going to specify the source file as the first argument. Then we're going to specify the O switch to specify the output file name, and also we're going to use the wall switch, which will catch any errors, or basically alert any errors should there be any. So running this command, the compilation process will begin, and if we actually list the dropper executable now, notice how much significantly smaller in size the executable is. And this is exactly what we've been trying to show you. Because it has such a smaller executable size, it now has a smaller surface area for detection. This is the power of Stages. By creating our own implants, or quote unquote droppers, we are able to customize them just as we want them to. Now, I hope all of this makes sense, but let's actually see what happens when we execute it on the victim. Now, we've uploaded the dropper onto the victim system, and if we actually run the dropper, you'll notice that no prompt was raised, but instead we have this ugly command line prompt. Now, there are ways to actually mitigate this, so it starts minimized. But if we actually go back to our attacker system, we'll see something interesting. Notice that a session has been established. And if we run the sessions command here, we'll see that indeed we have a fully working session. Now we can use the session and interact with it as we please, as it is a fully established session. Now, everything works exactly the same as a basic stageless payload, but what we did is that we created our own custom dropper, and the dropper fetched out back to the Sliver server to fetch its remaining shellcode. It took that shellcode and injected it to memory, and then fully established a session. So I hope you can kind of start seeing really how valuable, as the name suggests here, a implant of such can be. And as we proceed through our course, we'll discuss them more in depth. And that is it for stages. I hope you enjoyed. And as we proceed, we'll now get into reconnaissance, phishing, privilege escalation, and the very exciting stuff. It's been your host, Tennis, and I will see you in the next one.